Hey everybody, here's a little bit of Dano engineering I wanted to go over with you. What happens sometimes, a lot of times, actually more often than I'd like, is that the car that I'm working on is far away from the house. And with that I have to run long cables. When you have long cables, the longer the run, the more the amperage drops. And that's when the welder isn't getting its full power, not making the best welds. That's when my compressor won't kick, and stuff like that. So especially when you have these older houses like this one, it's very typical to have inefficient electricity. They call it dirty electricity because we know that a 115 circuit or electricity current, it runs anywhere from 115 to 120 volts. At the same time, the uh, the cycles are anywhere from 50 to 60 cycles per second. So if I'm on the 115 end of it and I'm only getting 50 cycles, that's where I run into problems. So what I did was I built out Goldie with with a bunch of different things in mind, and this is one of them. I'm going to show you. What I've got over here are six batteries, six car batteries, three on each side, and here's the cable that carries that current is 4/0. I mean, it's some big cable. So if each one of those batteries is 600 volts, I'm sorry, 600 amps. That's about 3,600 amps of power going into this inverter, and the inverter is a 3,500 watt, and it peaks at 7,500 watts. So, and what I do is I'm running a battery charger. So as you see right now, I'm not working it or taking any putting any load on it. So those batteries are charging up. So when I go to draw on it, it has quite the punch. I mean, it's definitely a full 30 amps, a good 30 amps, and that'll get it going. Like here's my compressor. Even when I have it plugged in over by the house, the cord still has to go into the basement, and it's too far of a run. Then I have to push the air all the way across here to my work area. So watch this. Usually when the first way I find that I've got a weak circuit going on, or low power, is the compressor really bogs. It's hard to start. It trips its motor breaker. It's just all that. But watch this. When I got this right now, I'm only pulling just over a half amp. That's my refrigerators and other 12-volt items that are running right now. But she fires right up. That's where it's at. Here, let's see. Pulling 14 amps. She's pulling 14 amps, and I got the welders inside over there, and it's running. And I got the shortest cord that I've got, which is about 20 feet. So that's how I roll with this MacGyvering engineering. When Goldie packs more punch than household current, I know I got something going on. I know I got it right. It's still when she's running. Because I've got a 140 amp battery isolator on there. I put a new alternator in last week, so when she's running, that alternator can produce about 105 amps, and I can run the AC up there while it's out through the inverter, using the batteries as the ballast and the inverter to do its thing, and everything works. I think I'm going to end up with 2 more batteries up on top so that I can run that AC at night when I'm fully off grid. That's just another engineering balancing act. So that's Dano's Power Station, also known as Goldie. Until then, once again, love you all. Thank you, and have a nice day.